So thank you. So up next is the open problem session. And in his remarks, when Ken Goldberg opened up Wafer, he gave an example of what used to be an open problem that was very succinctly defined, which was to create some sort of 3D shape that had that one stable point and the one unstable point. And we all got the result of that years of research in our welcome bags. So that problem was solved, and so in this session we want to talk about open problems that are still open, for which there is sort of a nice concise definition, and for which we can have a discussion to sort of understand the problems, and to the extent possible to try to make progress on it. So this particular thing, if you actually look it up, it took 11 years between when the original problem was stated and when this particular shape was come up with. So here we'll have at most 15 minutes to talk about the open problems. So we might not necessarily solve them, but the goal is to understand them and to make progress to the extent that we can. So Yor is now going to introduce our first problem and introduce our first presenter.
Yeah, so is this thing on? Yeah, it's on. So the first problem is actually also relating this shape, and just to give a little bit an idea of a good, succinct open problem. And so Ron already said it, it has one stable equilibrium and one unstable equilibrium, and also it has uniform density, right? Very important. So the open problem is there a polyhedral version of this? And according to Wikipedia, there is actually a reward of $10,000 minus the number of faces on that polyhedron. If you can solve it, right? That's the open problem. Okay, who's next? Aaron? Yeah, go ahead.